Okay, Algebra 2, this is your Chapter 4, second half quiz review. Got 8 problems. Let's get started. So we need to solve this equation by finding square roots. And to do that, we need to get the x squared, and I'll try to circle it, all alone. This says 5x squared minus 40 equals 0. So I will do two things. First, I will add 40 to both sides to give me 5x squared equals 40. And again, I'm still looking to get that x squared all alone, so now I'll divide by 5. And I'll get x squared is equal to 8. And now I will take the square root. When I take the square root, x comes out, and you get two answers. X equals positive square root of 8. X equals negative square root of 8. You get two possible answers, and now you must look to simplify 8. Now, if I do it here for the square root of 8 here, it'll be the same for the square root of 8 there. So we're going to work on the left side first, the left square root of 8. 8 can be broken into 2 and 4. 4 is a perfect square, 2 squared. 2 cannot be broken down, so I need to rewrite it. I need to circle it and include it in my square root. So we have x is the square root of 2 times 2 squared. Anything squared comes out, so 2 comes out, the 2 squared disappears, but this 2, since it is not squared, stays inside the radical. And there is one answer, positive 2 radical 2. The other answer is then going to be negative 2 radical 2. And there's your two answers, positive and negative. Be careful simplifying those square roots. 2. It says your class is selling boxes of flowers, seeds as a fundraiser. The total profit P depends on the amount X that your class charges for each box of seeds. The equation P equals blah 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 is the model for the profit of the fundraiser. What is the smallest amount, okay? What is the smallest amount in dollars that you can charge to make a profit of at least $125? So, profit equals 125. So we're going to use this equation, and we're going to plug 125 in for P. 125 equals negative 0.5x squared plus 25x minus 150. And this is going to require the quadratic formula. So to use the quadratic formula, your equation must say equals 0. So let's get this 125 to the right by subtracting it. Notice I'll put it underneath the negative 150 that's over there. The left side cancels, and I get negative 0.5x squared plus 25x minus 175. And now I am in standard form. I have my A, which is negative 0.5, my B, which is 25, and my C, which is negative 175. And I will use the quadratic formula. The quadratic formula says x equals the opposite of B, plus or minus the square root of b squared minus 4ac all over 2a. And I like to do the discriminant first, which is the b squared minus 4ac part. So we'll do b squared minus 4ac equals 25 squared minus 4 times a times c. So we use our calculator, 25 squared minus 4 times negative 0.5 times negative 175. I'm sorry. We need to fix this. This is 275. I apologize. Fix this right now. 275 negative 275. Make sure you fix this. All right. Your answer will be off. So 275. I apologize. So negative 275, and I get 75. Okay? So that's my discriminant. So in this equation, this quadratic formula, I will put the opposite of b. b is 25. The opposite of 25 is negative 25. Plus or minus the square root of my discriminant, which I just found was 75. All over 2 times a. a is negative 0.5. 2 times negative 0.5 is negative 1. And now I'm going to take the square root of 75. This is a word problem, so we are going to use decimals, and it's money, so we're going to round to 2. So the square root of 75 is 8.66. So I will replace this with 8.66, and now I will have two possible answers, negative 25 plus 8.66 over negative 1, and negative 25 minus 8.66 over negative 1. And I'll use my calculator in both cases. So the top one, negative 25 plus 8.66 divided by negative 1 is 1634. And the bottom one comes out to be negative 25 minus 8.66 divided by negative 1 equals 33.66. And the question is, what is the smallest price that they can, smallest amount they can charge? And that would be the small number, $16.34. Okay. And there you go. So that's a quadratic formula practice problem. All right. Next, number 3 here. Business. The weekly revenue for a company is given by this, where P is the price. Use the discriminant to find whether there is a price for which the weekly revenue will be $1,500. So will revenue be $1,500? Well, let's plug it into the equation. So 1,500 equals negative 3p squared plus 60p plus 1060. And again, p is your x. P is the price. Make this say equal 0 by subtracting 1,500. 0 equals negative 3p squared plus 60p. This becomes minus 440, right? 1060 minus 1,500 minus 440. And now I'm going to use the discriminant. Remember, the discriminant is just the part under the square root. B squared minus 4ac. In this problem, a is negative 3, b is 60, and c is negative 440. So we go ahead and fill this in. B is 60 squared minus 4 times a times c. And we get 60 squared minus 4 times negative 3 times negative 440. And I get an answer of negative 1680. And this is a negative discriminant. The discriminant is less than 0. When the discriminant is less than 0, there are no real solutions. So the question is there a price for which the revenue will be this much? No. No price. Because you have no real solutions out of this equation. All right. So that's how we can use the discriminant. All right. All right. Moving on. Now we're going to look at some complex numbers. These a plus bi's. So we need to plot each number, plot the number, and then find its absolute value. So 3 minus 6i, remember this is a plus bi form, so in this problem a is 3 and b is negative 6. When you graph this, and I'll just do it right here, remember the x is the real and the y is the imaginary. The real part is a and the imaginary part is b. So to go 3, negative 6, you go 3 to the right for the a, and then 6 down for the negative 6. 3, negative 6. And there's where 3 minus 6i is located, right there. And now we're looking for the absolute value. And the distance from 0 to that point, this is the absolute value. I'll do ABS. Absolute value. Okay? And to find the absolute value, so to find the absolute value of 3 minus 6i, remember, use these bars, we're going to take the square root of a squared plus b squared. So that's the square root of 3 squared plus negative 6 squared. And this should come out to be a positive number, 9 and 36. Positive 36, that's the square root of 45. And now we need to look to break down 45. And I'll do it right here. 45 is 9 and 5. And 9 is a perfect square of 3. 3 squared. 5 cannot break down, so we have to circle it. When I rewrite 45, it is 3 squared times 5. The 3 comes out, and the 5 goes inside because it's not squared. And there is its absolute value, 3 radical 5. The distance it is from the origin. Okay. Next, let's do some operations here. Let's simplify this. And if you look here, right, you see this minus sign right there. This means subtraction. And to subtract, we are going to distribute the minus sign. So the first parenthesis stays the same, 12 plus 5i, but we drop the parentheses. And then the second one, we distribute the negative. So that positive 2 becomes negative, and that negative I becomes positive. And now we combine the real with the real. 12 minus 2 is 10. And the imaginary positive 5 with the imaginary positive 1i. 5 and 1 is 6i. So again, be aware of the sign in between. Do not multiply these two complex numbers together. Distribute the negative and just combine the like terms. Division. Here we go. So to divide, remember, we need to get I out of the bottom by using the conjugate. So we use the conjugate of the denominator, and that is the same complex number, but you change the middle sign. Negative 1 plus 4i. That'll be what I multiply the bottom by. That'll also be what I multiply the top by. Negative 1 plus 4i. And in the top, we are going to FOIL this, or multiply it out. Okay? So 4 times negative 1 is negative 4. 4 times positive 4i is 16i. Negative 3i times negative 1 is positive 3i. And then negative 3i times positive 4i is negative 12. And I is I squared. And now immediately, I squared is negative 1. Remember this, I squared equals negative 1. So it makes negative 12 turn positive. Now, when you multiply the bottom together, the bottom comes out to be a squared plus b squared. The I goes away. So a is negative 1 squared plus b is negative 4 squared. So now what do we get? Let's go left to right. So in the top, combine negative 4 and positive 12 and get 8. Combine the 16i, positive 16i, and positive 3i. That's positive 19i. And on the bottom, we square these, which makes them positive. 1 plus 16 is 17. And then you separate. 8 over 17. The middle symbol goes in the middle, plus 19 over 17, and the I comes at the end. Now, if these simplify, you need to simplify them, but 8 and 17 and 19 and 17 do not. So that is it. 8 over 17 plus 19 over 17i. So remember that conjugate idea. Just change the middle symbol, multiply top and bottom, and you'll get a squared plus b squared in the bottom. Okay. All right, that's a toughie. All right, next one. We have 2 more left. Find all solutions to the quadratic equation. Okay. And here's my equation. We're going to use the quadratic formula, so we need it to say equals 0. So to make that happen, let's subtract 4x. There is nothing that it will combine with, so just subtract it somewhere underneath. And put it in standard form. Highest power first, then the next, then the number, equals 0. And now this is in standard form. My a is a 1. There's a 1 there. My b is a negative 4, and my c is a 5. And we are going to use the quadratic formula. Quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I will first find what b squared minus 4ac is. B squared is negative 4 minus 4 times a times c. That is 16 minus 20. That's a negative 4. Uh-oh. Your discriminant's negative. Think about what that means. Plug in your numbers. Opposite of b. B is negative 4. The opposite of negative 4 is positive 4. Plus or minus the square root of your discriminant, which is what you just found. Negative 4 all over 2a. A is 2. A is 1. 2 times 1 is 2. Now when I see this negative inside the radical, immediately, I radical 4. Right? The I comes out, the negative goes away. And now I look at 4, right up here. 4 is just 2 squared. So when I write this, it's going to be 4 plus or minus I square root of 2 squared all over 2. And this 2 comes out. So if I keep going down, 4 plus or minus, this 2 comes out in front of the I, 2I. The 2 inside the square root goes away, so the square root's gone now, all over 2. And then the last thing you do is you look to simplify these 3 numbers. Each is divisible by 2. So you get 2 plus or minus 1I over 1. So your most best. The best answer is 2 plus or minus I. And those are your solutions to this quadratic equation. So you get 2 imaginary solutions. Okay, last problem here. Solve each system. So remember, we are looking for where these 2 graphs intersect. And to do that, we are going to set y equal to y. That is, the top and bottom equations equal to each other. Negative x squared minus x minus 3 equals 2x squared minus 2x minus 3. And what I will do is I will move everything to the right to keep the x squared positive. So I'll add x squared, I'll add x and add 3. I'll add x squared, I'll add x and I'll add 3. So cancel, 0. 3x squared minus 2 plus 1. Minus 2 plus 1 is minus 1x. And the 3's cancel. And now we have this. 3x squared minus 1x. And again, sometimes you'll have that c where you have to, factor it using the c and then finding the b. But here we only have 2 terms. So what do? Well, we look for a common factor. Greatest common factor. 3x squared minus 1x. The 3 and 1 share no common factor, but they both have an x. X is your greatest common factor. Pull the x out. 3 stays. X squared becomes x. Minus 1 stays, and this x goes away. And here are your 2 factors. The multiplication's right there between the x and the parentheses. Set each one equal to 0 and solve. X equals 0. There's 1. 3x minus 1 equals 0. Add 1. 3x equals 1. Divide by 3. X is 1/3. You could also do 0.33. I don't care. But you have 2 x values that work here. Therefore, these 2 parabolas, these 2 quadratics, intersect at 2 places. And we must find those points. Right now we have 2 x values. You must find the y that goes with each of those points. So choose one of your equations. I'm going to choose the bottom one because of that negative x squared. I don't like it at the top. So y equals 2x squared minus 2x minus 3. And plug in your x values, starting with 0. So when I plug in the zeros, anything with x goes away, so the zeros go away, and you get y is negative 3, which means one of your intersection points is 0, negative 3. X is 0, y came out to be negative 3. There's 1. And now we find the second one by plugging 1/3 into this equation. 2 times 1/3 squared minus 2 times 1/3 minus 3. And you can use the ABC button, you can use the decimal, I don't care. Do whatever you got to do to get a number close to what I get. And I'm going to, so I get y is, and I'm going to use negative 3.44. So, I used 1/3 as my x, and my y came out to be negative 3.44. And there's the second place that these 2 quadratics intersect. So again, make sure you review your factoring. You have examples in your notes that you can use. Make sure your notes are all filled out. Thanks for watching, and we will see you on Wednesday.